meet our next speaker, Simon, who will present 30 years of Java, the history. Please greet with applause.
Okay, thank you very much. Guten Tag. That's unfortunately where the German stops. So, despite having a German name, I am not actually German. So, unfortunately, I did do German at school, but I didn't really stick. So, I will do this presentation in English. So, the idea behind this presentation is, as you would see from the title, is to explore 30 years of Java history. So, let's depress myself by starting off and saying, who here wasn't born 30 years ago? Was not born 30 years ago. Okay, so there are a few people, right. Because, so to give you a little bit of history about myself and why I would talk about 30 years of Java history, I started working at Sun Microsystems, I think it was February the 13th, 1996. And I started there not actually to do Java, but to do a thing called Solaris, which was a Unix-based operating system, a bit like Linux. And I could see immediately that Java was going to be something quite big, and I thought to myself, I need to get into this. So I kind of found a job in Sun doing some Java stuff, and then followed Java all the way through the Sun years, got acquired by Oracle, spent another 5 years at Oracle doing more Java stuff, and then for very nearly the last 10 years, in fact, tomorrow will be my 10th anniversary of being at Azul Systems, and I've done 10 years of Java at Azul. So that's why I can talk about 30 years of Java. The other thing I would say is that I'm a very sad individual, and by that I mean that I actually keep everything. What I found when I started putting this presentation together was the very first Java presentation I ever did. And this was back in early 1997. And it was actually in Norway somewhere. And I talked about Java. And the weird thing about this was it was a PowerPoint presentation, but I couldn't load it into PowerPoint on my Mac because it was so old. And PowerPoint wouldn't read it anymore. So the only way I could get it into my presentation was to actually use OpenOffice, the open source version, bring it into that, and then export it as a more modern version of PowerPoint. So that's just a little bit of history there. And my email address will not work anymore on that slide. So before we get into Java itself, let's talk about some of the history before Java. Where did Java come from? What were the influences of the people who created Java? And there were quite a few. So we can look at prehistory for Java. You can actually go all the way back to 1962. In 1962, there was the creation of the Lisp programming language. Anybody here ever tried Lisp? Oh, good. OK, a couple of people. Quite a few people, in fact. Well, this was the first programming language to use some of the things that we've seen in Java. So it used a sort of form of garbage collection. So it did some automated memory management. And it also used a form of just-in-time compilation, which they called compile and go. And that was not really like we think of just-in-time compilation today, because you have to remember that in 1962, we were using punched cards. So the way that it worked is you put the punch cards through once, and then you generate some new punch cards, and then put those through again. Moving forward to 1967, we had a programming language called Simula 67. Anybody ever tried that? No, I didn't think so, because I've very little known programming language. But it is important because this was the first object-oriented programming language. Java's object-oriented. This was the first object-oriented programming language. And the other thing that's important about Simula is it was the first programming language that James Gosling learnt how to use. So clearly had some influence on Java when it was created. Then in 1973, we have the C programming language. I'm sure several people here have tried C. The reason that's important is because when they created Java, they wanted to make the transition from other programming languages to Java easy. And to do that, they said, C is a very popular programming language. Lots of people use it. Let's take a lot of the syntax from C and move it into Java. Things like the switch statement, things like for loops, the braces, all of that is straight out of C. Then in 1978, we've got Pascal. Anybody did Pascal? Yeah. Okay, a few people did Pascal. Good. Yeah. Yep. I did lots of Pascal when I was at university. And this had, part of Pascal was what they called a virtual machine. So the idea of interpreting the code based on something that was not quite source code, but not quite native instructions. It was called P code. So it was sort of like really, in terms of P code, it was more like intermediate representation that you get from a compiler. But it was something like a virtual machine, and again, heavy influence on what we have in Java. And then the last thing that we can look at as a sort of precursor to Java was the introduction of the World Wide Web back in 1991. And in 1993, we had the Mosaic browser. Anybody use the Mosaic browser? Nobody? Oh, one person. Okay, good. So Mosaic browser and then Netscape. Anybody use Netscape? Yep, a few people using Netscape, right. So all these things were part of the prehistory of Java. So then, okay, these pieces are all together. Where did Java actually come from? And for that, you need to go back to 1991. And what really kind of kicked this off was Patrick Norton, so the second on the left there, and he was playing ice hockey. He was playing ice hockey with Scott McNeely, and he was getting a little bit disheartened with working at Sun Microsystems. Sun Microsystems had been around for a while, and it was a very technical company, but it was now starting to grow and sell more things and become more commercial. And he's getting a little disheartened with that because he wanted to be more technical and looking at the next big thing and seeing what was going to happen. And he said to Scott McNeely, told him about his concerns. And Scott said, write me a letter and tell me what you want to do. So Patrick wrote him a letter explaining what he wanted to do in terms of looking at the next big thing. And the response he got back from Scott was, maybe you guys are onto something. Why don't you go hide away somewhere and think about what it is? So that's what they did. So there were a group of them, the 4 people here, Ed, Frank, Patrick Norton, Mike Sheridan, James Gosling. And they went away to start a separate project. Now, to do that, they decided that they wouldn't be part of Sun exactly. They'd go off campus, and they'd find an office somewhere else. So they found a place which was in Menlo Park, south of San Francisco, and it was above the Bank of America in Menlo Park. And they said, right, we are going to start our own project. What are we going to call it? Now, this is where things get interesting because, of course, in computer science, the 2 biggest problems are cache invalidation and naming things. And the third one is really the off-by-1 problem. So they looked around and they said, right, what are we going to call our project? And they said, okay, well, the door to the office is green. Let's call it Project Green. And so that is where Project Green originated from. It was the color of the door in the office. And they said, right, what are we going to do? And, sorry, did you want to take a... I'll leave that up there for a second. So they said, what are we going to do? And they came up with this idea of a device. And this device was going to be like a remote control, but on steroids. What they wanted to be able to do is have people use this remote control, interact with devices around their house or their office, things like televisions, things like, for those of you old enough to remember, VCRs, video tape recorders, and be able to program them and do all sorts of things with these devices. And it was, in many ways, it was a great kind of like forethought of what was going to come. Because what they created was this thing called the Star 7. And the Star 7 is very much like if you look at an iPad today. It had a screen, touch screen, it had the ability to interact with things and all sorts of things like that. So, of course, the first thing you have to ask yourself is, why is it called Star 7? And the answer to that, again, is that the developers said, right, we need a name for something. Okay, we're not very good at naming things, so they looked around and they said, oh, the telephone. On the telephone, if you want to answer any of the extensions for that office, you press Star 7. And so that's why they called it the Star 7. Like I say, it was like an early iPad, but a very, very resource-constrained one. So it had literally 4 megabytes of RAM. Not gigabytes, megabytes of RAM. Used a MicroSpark chipset, which was the one that Sun had developed as part of their sort of hardware and so on. It had a very slow radio link at 200 kilobits per second. had a TV screen, touch screen, only single touch, not multi-touch, and various other bits and pieces like IR control and so on. And if you go on Google, YouTube, if you look for the Star 7, there's a really good video of James describing this and actually showing what it can do. And so I took a screenshot of that from the top there. And literally is where you walk through a virtual environment, you go up to the VCR, you can program it, you can do all sorts of things like that. So it's well worth watching to see what that could do. Another part of this project was the idea that you would have some kind of programmability, so apps that would run on this device. When they thought about that, they said, right, we need some way of developing these apps. James Gosling was the one who was tasked with this, and he started off with C++. And he said, right, we'll use C++, but I think I need to make a couple of changes to the way C++ works. So he started making some changes, and eventually he got to the point where he'd made so many changes, he thought, yeah, let's not call it C++ anymore, let's call it a new programming language. Once again, we're faced with the issue of how do we name something? So James was like, looks out the window and there's a tree. So let's call it Oak, because it was an oak tree outside his office. You can see there's a bit of a theme going on here. And when he created this language, he described it in this way: a simple, object-oriented, distributed, interpreted, robust, secure, architectural neutral, high-performance, multi-threaded, dynamic language. Clearly, James should have been in marketing, not in the technical development side of things. But that's a very good description of what he came up with. And it was very important because the whole idea, one of the fundamental ideas, was moving code around the network. And if you want to move code around a network, then you have to face certain issues of distributed computing. Primarily things like security. You need to make sure you can't move viruses around your network. You need it to be architectural neutral because you want to move it from one device to another, and they may not all use the same chips, they may not all use the same architecture, and so on. So all of the things he said here in terms of like performance and object-oriented and distributed and interpreted, all of these things were very much the idea behind Java. So then again, in 1992, one of the other things that they decided to have on the Star 7 was the idea of some kind of character that could help you if you didn't quite know how to complete a particular task. A bit like a sort of the idea of Clippy, if you remember, from Microsoft, who helped you out with various things. But they came up with this beforehand. So initially, they created this sort of character that would appear on the screen to guide you through different tasks, and they called it the agent. And then they decided, okay, we're not going to call him the agent, so he became Fang. And the reason he became Fang was some people said he looks a bit like a tooth, which I think is pretty unfair, but maybe. And then, of course, he became who we all know, which is Duke. And you can see the little tumbling Duke there, which was one of the sort of very first applets that was created for Java. Duke was very popular. He's still the mascot, if you like, for Java. And he even had his own comic. I actually have a copy of that comic here. It only actually had one edition, never made it to a second edition. And if you want to, again, Google it. Somebody scanned it, and you can actually read it on the web, and you can see what it was. It was basically a sort of marketing thing that they created at Sun at the time. Before Duke came about, or the agent or Fang, they actually had a different character that was called Greenbot, and that was the sort of person or character that was going to be the assistant before Duke came about. I actually think that Duke is better. I much prefer the look of Duke rather than Greenbot. The other thing that happened in 1992 was that the team that had created this project, the Green Team, became a separate company sort of outside of Sun, and it was called First Person Inc. And they actually created a specification for the Oak programming language. And if you go online, you can, again, download this, and you can see there's some quite interesting things where the programming language, not so much the syntax, but some of the reserved words are actually quite different to the ones that we have in Java now. So that, for example, I think there was one which is unprotected, which is kind of weird. I don't quite know what it did, but they had some different keywords there. The other thing that happened was that the project started to sort of falter a bit. And they put forward a contract, or bid on a contract from Time Warner, who were doing set-top boxes. And because of the work they'd done in terms of programming video recorders and things like that, they thought that would be a good application of Java and some of the technologies they'd been working on. But they lost that bid. And so some of the developers who'd been working on the Green project, they said, okay, this is not really working for us. We're going to move back to Sun and take on other roles there. But the core team kept at it, and they didn't give up. And then in 1994, this is when things really kind of coalesced and everything changed. And the reason for that is that some of the work they'd been doing, they kind of pivoted a bit and started working on this thing called WebRunner. And WebRunner was a browser that was based on the Mosaic browser at the time, but had a lot more functionality in it and differences and things that you could do. And so John Gage, who was the chief scientist at Sun Microsystems at the time, popped his head into James Gosling's office one day and said, have you got an Ethernet cable that I can borrow? And James said, yeah, sure, you can borrow this one. What do you want it for? And John said, well, I'm going down to Monterey to this conference called TED. Now, back in those days, TED was nowhere near as widespread as it is today. But it was the idea of putting forward interesting new ideas around education and things like technology and things like that. So James said, what are you going to demonstrate? And it was like, well, the stuff you've been working on, WebRunner and so on. So James said, right, if you're going to do that, I'm coming with you to make sure everything works. So off they went to Monterey. James spent a lot of time setting everything up, getting it all working, making sure it ran. So the next day, John gave this presentation, and he put up this web browser. So the audience was looking at it, and they're going, OK, it's a web browser, it's like Mosaic, so what? And one of the things on the screen was a picture of a molecule. As you can see in the bottom right-hand side there, there's a molecule. Great. Everybody was just going, yeah, it's another web browser, so what? And then John clicked on it, started dragging it around, and it moved. And then he kind of pulled it apart, put it back together again, and suddenly everyone went, ooh, interactivity on a web page. That's a real game changer. Suddenly, everything is no longer just static content. People can do all sorts of different things through that web browser. And that's really where the ideas behind the sort of Java came from. So in 1995, this is where we get to the 30-year anniversary, Sun released Java. And effectively, they released two things at that time. They released Java, the programming language, and Hot Java, the browser, which was the thing that was based on this WebRunner idea. And really, at that time, Sun was trying to push Hot Java, the browser, more than Java, the programming language. That was what they really focused on. One of the things that they also did was just before they released Java initially, they came up with a deal with Netscape to include Java, the programming language, into the Netscape Navigator. Because Netscape was the most popular browser at the time, that gave them a lot of coverage for the technology that they wanted to make widespread. So it was very good from that point of view. So I put a number of names here. There's Silk, DNA, Lyric, Pepper, NetProse, Neon, Ruby, WebRunner, WebDancer, and WebSpinner. All of those were potential names for Java. The reason they didn't call it Oak was because Oak had already been trademarked. They needed to come up with something else. So they thought of all sorts of different names, and these are the ones they kind of came up as their sort of short list. So we could, theoretically, have been celebrating 30 years of Silk, or 30 years of Neon, or 30 years of Ruby. Oh, hang on, we already have Ruby. Well, anyway. So they called it Java, and that's what it became. So this then really started getting people excited about the whole idea of Java. And Sun came up with the idea of, right, we really want to focus on this. So they took the first-person company, brought it back into Sun, and turned it into the JavaSoft division at Sun Microsystems. What these people were tasked with was coming up with all sorts of ideas about how Java could be applied in all sorts of different places, different technologies, and so on. So one of the things they did was they created the Java operating system, an operating system written entirely in Java. It didn't really go very far. It was, a nice idea, but never kind of caught on in any particular big way. The other thing that they came up with was the idea of the Java station. And this was an appliance that had processing power and memory, just like a PC, but it was focused on just providing a web interface. And that way you'd run all your applications or your applets through the browser, and you'd have all the Office functionality and everything like that. It was more of a sort of replacement for the dumb terminal that you would have had before. So for those of you, again, old enough to remember things like the VT100 terminal or the WISE 50 terminal, then it was a replacement for those. The initial one was called the Mr. Coffee, and that was a sort of just a rectangular box, which was not very exciting. I did have one of those when I was at Sun, but what I really wanted was the Krups, because that's the one you can see in the picture there. It's much more curvy, much more interesting looking. But I never managed to get one of those. The problem with this was it was woefully underpowered. It literally had 8 megabytes of memory. So you were trying to run an operating system, a Java virtual machine, which only did interpretive mode, there was no JIT compilation, and your applications. Everything ran really, really slowly. And it just didn't take off. So there was supposed to be a super Java station, which was going to use some Java chips, but that was one of those things that never saw the light of day. Sun did come up with a sort of replacement for this at some point, which was called the Sunray. Don't know if anybody's ever used one of those or remembers those. Then in 1996, things got even better because Microsoft, who had created the Internet Explorer browser, said, oh yes, we will include Java into that. And that was great because it meant that we had Java on Netscape, we had Java on the Hot Java browser, we had Java on Internet Explorer. Everything was great. Right. Now I want to take a brief interlude here to talk about version numbering with Java. So we've seen that naming things is difficult. Well, if you think naming things is difficult, numbering things is even worse. Right, so when they released Java initially, they called it Java 1.0. Pretty logical, I like that, good, 1.0. And they gave it an alpha extension just to say that this was not the first release, this was just for trial, just to get things going. Then we move into like how Java version numbering continued. So we had Java version 1.0, the initial release of the JDK, which was around January, I think, of 1996. And you got a version string from Java, which was Java version 1.0. Again, very logical. And we had a couple of updates to that, which was 1.01 and 1.02. So far, so good. Then we came up with the next version of Java, and they called it Java 1.1. You could argue, and we'll come back to this later, that that could have been Java 2, but no, we'll call it Java 1.1 in terms of an update with some changes and new features and so on. And that maintained the same idea of the version strings at 1.1, all good. Then we got some updates to that. So we got 1.1, 2, 3, 4, 5, 6, 7, 8. And then we got some updates to the updates, which we got 1.1.7a, 1.1.7b, and then after 1.1.7a and b, we got 1.1.6_004. Okay. Then we got Java 1.2. Okay, still some logic there, so we're just incrementing the number again. Good. And we still get the 1.2, but now we'll add a 0 as well, just to keep you on your toes. Of course, then we introduced the idea of Java editions, because Java was getting much more popular, and there was the idea of applying Java in lots more places. So we ended up with Java Micro Edition, which was a small embedded devices, mobile phones, that type of technology. Java Standard Edition. This is the core programming language, the idea of the language syntax, the virtual machine specification, the libraries, and so on. And good old Enterprise Edition, which is now Jakarta EE, which was all the servlets and the app servers and the EJBs and things like that. So marketing gets involved, and they decide that we need to have a rebranding of Java in terms of numbering. So we have Java 2 SE. Great. So this is very logical, except marketing and engineering collide, and we end up with Java 2 SE 1.2. And we're going to get 1.2 in the Java version string as well. And I will read this out because I found this online. And it says, while 1.2 was a remarkable release from the perspective of the amount of change, it had the version 1.2 versus 2.0, and it was clear there would never be another major release. Consequently, minor releases, 1.2, 1.3, were referred to as major releases, and micro releases, 1.3.1, 1.4.2, as minor releases. Retrospectively, 1.1 is also referred to as a major release, though 1.1.1, 1.1.2 continue to be micro releases. Anybody understand what that means? I have no idea. Yes. So we continue with our version scheme, numbering scheme. So then we end up with Java 2 SE 1.3. So we're moving forward, and we get the same version string, okay, so that's all good, and an update 1.3.1. 1.4, we're still moving forward. Logical, yes, it's all good. And then we get Java version string, same, 1.4.1, 1.4.2. What do you think the next version is going to be? Java 2 SE 1.5? No, it's going to be Java 2 SE 5.0. Reason behind that was that there were lots of changes in Java SE 5, as we'll see later on. And that said, marketing said, yes, we need a bigger number, so it's 5.0. And engineering were still not buying into this, so we got Java version 1.5.0. Then marketing said, right, hang on, we're getting confusing here, so we'll clean things up. Now we'll have Java SE 6. We'll drop the 2, because there's never going to be a 3. Well, because we've got 5 already, so that doesn't make any sense, so yes. And we'll drop the .0 because we know there's never going to be a 6.1. And then we keep the same version string, and then we do Java 7 and Java 8. All good. Finally, with Java 9, we get a difference because they said engineering finally bought into the idea that we don't need the 1 point in front of it. So we get Java version 9 and some updates, which is 9.0.1. Which has a definition, which is a JEP, and that says it's major release, minor release, and security release. So you think at this point, great, we're finished, we're done. Well, no, we're not. Because then in September 2017, Oracle announced that we were going to move Java forward faster. And this is when we switched to the 6-month release cadence for Java. And so you'd think that the next version after JDK 9 would be logically JDK 10. Oh, no, no, no. There was an idea not to call it JDK 10. Let's call it JDK 18.3. Really? How does that work? Well, actually, the idea that they came up with is 18.3.4 as well, which is $year, or year, month, and age. So the year would be the year it's released in, 2018. The month would be 3, which is March. And the age is when you have an update, it's the number of months since the first release. So if it's 4, then it's 4 months after March, which means it's July. Thankfully, that didn't make it. So we had Java SE 10. And finally, we have the final version, which is feature interim update patch. The only thing that I don't like about this is if you read the JEP, it says that interim is always 0. Well, if it's always 0, why do we have it? Anyway, back to the Java story. So in 1997, here we have 2 people. We have, on the left, we have Scott McNealy, the CEO of Sun Microsystems. On the right, we have Steve Ballmer, who I think at the time was the CTO of Microsoft. And they're smiling and they're very happy. Oh, that did not last, because Sun sued Microsoft over their implementation of Java in Internet Explorer 4. The reason behind this was that Microsoft, being the way Microsoft was at that time, they said, yes, we like Java. We think we can make it better. And the way we'll make it better is by adding some extra APIs into the Java namespace. And we'll also, we don't like some of the ones that are there, so we'll remove those and just leave them out. Which obviously means that the idea of write once, run anywhere doesn't work, because if you write code for the Microsoft version of Java, it might not work on the Sun version and vice versa. So Sun said, no, that doesn't work for us, so you're not in compliance with the license that we gave you, so we're going to sue you. And eventually they settled for $1.9 billion. That's what Sun got from Microsoft. And Microsoft said, right, that's it, we're done with Java. Let's do C# instead. 1998, there was a sort of groundswell of opinion that we should have more openness for Java. And they wanted more openness in terms of standards and more openness in terms of source. So a group of people got together and they created this thing called the GNU ClassPath project, which is all about creating an open source implementation of the standard class libraries. Now, the reason they called it GNU class path is because they couldn't use the word Java. Java was trademarked by Sun, and Sun wouldn't let them use it. So as good computer scientists, they solved the problem by using a level of indirection. They said that in the class path, you will have the word Java somewhere. So we'll just indirect through the class path and call it the GNU class path project. They also had a couple of other things that sort of sat around that. There was GCJ, which was their compiler that they wrote, and they even had a virtual machine that they started working on called Jaffa. Then in 1999, Sun decided that they would start making Java more open in terms of standards. And they said, right, well, yes, we want to make it more of an open standard, but we don't want to just hand over control to some independent body like ANSI, where you've got C, or the European Computer Manufacturers Association or something like that. So rather than do that, they created their own standards body, and it's called the Java Community Process. Within that, there are things called JSRs, Java Specification Requests. And each JSR has 3 different parts to it, which is the specification itself. In the case of Java, it's the language specification, the virtual machine specification, and the core class libraries. There's also a reference implementation to show that you can implement that specification. And then very importantly, there is a thing called a TCK, a Technology Compatibility Kit. And that's a set of tests that you can use to run on an implementation you have created of that standard to prove that it matches it, and therefore you can call it Java. So this has been going on for like 26 years, still doing things at the JCP. I was at a meeting of that recently in Cambridge in the UK. The other thing that happened was this idea of open source continued, and there was this project in the Apache Foundation called Harmony, primarily led by IBM, but with lots of other people sort of contributing to it. And for several years, this was something that caused a lot of problems in Java. The reason it caused a lot of problems was because the Apache Harmony project wanted to create an open source implementation of Java. They were working on writing it, the IBM engineers were working on it, but in order to prove that it was Java, they needed the TCK. And Sun wouldn't license the TCK to the Apache Foundation. So this caused a lot of slowdown, because if you look at the release of JDK 6, that was at the end of 2006, and it wasn't until 2011 that we got JDK 7. So 4 years between releases. And the reason for that, a large part of it, was because of Apache Harmony. Because they couldn't get the TCK, Apache, who were part of the JCP, said, that's it, we're not signing off on any of the specifications until we get access to the TCK. Sun said, you're not going to get the TCK, so we didn't get any versions of Java. Of course, at the same time, Sun then decided to open source Java themselves and create an open source implementation of what they had been doing. And they called this OpenJDK. So in 2006, they announced this, and they released the code to the Hotspot virtual machine and the Java-C compiler. They couldn't release everything all at the same time because they had to do a lot of due diligence, because lots of other companies had contributed code to the code base over the years, and so they had to go through and carefully make sure that they had the rights to open source everything. So it wasn't until 2007 they actually released almost all the remaining code, but even then there were still some bits that were what are called binary plugs, so you had to have binary things primarily around fonts and color rendering and things like that. It was actually JDK 7 build 53, which was the first one that you could build completely from open source. So then things carried on for a little bit longer, and then we hit 2010. And I very much remember this period of time, because I remember April in 2009 getting an email in the morning, and it was like, Sun is being acquired by Oracle. I was like, oh, yes, insert your favorite expletive here. So Sun was acquired by Oracle, and we ended up with Sun Oracle, briefly. That was the kind of logo that they used briefly for a couple of the machines that they made. And then James Gosling did a picture of Duke and Tux lamenting the death of Sun, or the end of Sun as a company. So this then led to some changes. So Oracle took over, and they now had the trademark for Java, and they had the engineering team for Java and so on. And they said, right, we need to get things moving because there'd been a lot of delay over new versions of Java. So they went to the Apache Foundation and they said, right, we are not going to give you the TCK. You have to accept that. And they also talked to IBM, who were obviously heavily involved in the Apache Harmony project. And eventually, they came to a conclusion that the Apache Foundation would leave the JCP, they would abandon the Harmony project, and IBM would then devote its engineers and its resources to the open JDK. And that's how things kind of moved forward. So the other thing that happened in 2011 was we started changing how Java gets developed. We moved away from the idea of just a JSR or just component JSRs to define pieces of technology. And we moved to the idea of using JEPs, JDK enhancement proposals. I'm sure you've all seen the JEPs that we have nowadays. The idea behind this is so that you can have smaller pieces of work, you can define new features in a smaller way rather than having big definitions and so on, and it can affect all parts of the JDK, because Java SE doesn't cover everything that you've got in the JDK. So if you look at new versions of Java now, you'll find there's a set of JEPs, and all of those JEPs get included into the JSR, which defines what that version of Java SE is. And so we ended up in 2018 with this idea of moving Java forward faster. And this is quite interesting because what it's done is it's allowed us to go to a time-based release schedule for Java every 6 months rather than a feature-based release schedule. So now we have clear times when every March, every September, we get a new version of Java, and we get much more. I think it's actually led to faster development of features than we had before. It's also led to some other interesting things, which I'll talk about a little bit later on. The other thing that happened is Oracle changed their licensing. You may be aware of this, how they license the Oracle JDK. And what that's led to is a proliferation of distributions of OpenJDK. So we have Corretto from Amazon, we have Temurin from Adoptium, we have Azure Platform Core, and Microsoft even have their own distribution of OpenJDK. I do find that we've come full circle with the idea of Java and Microsoft, but they're a very different company now. So the other thing I want to look at is where Java ended up. So there are lots of different places where Java got deployed, and what sort of things did it end up in. So I took this was a cover of a marketing thing that we created when we were at Sun called Java Everywhere in Action. So the first thing was Java Card. This was the idea of running Java on a very, very, very small device. So literally where you've got less than 1 megabyte of memory, often sort of 640K of memory, that kind of thing, and very constrained resources in terms of processing power. But if you've got a mobile phone and you still use a physical SIM, you're actually using Java Card. If you've got, if you've got an Oyster card, if you travel in London, that uses Java Card. There are lots of examples of ID cards around the world where they use Java Card to do that kind of thing. It's not a full VM implementation, so it doesn't have dynamic class loading, it doesn't have multi-threading, funnily enough, it doesn't even have char, double, float, or long. So it really is a cut-down version of Java. But it does run a sort of virtual machine. I mentioned briefly the idea of Java chips. This was something that came about in the early days of Java. The reason behind this was that because Java used an interpreter for the virtual machine, it was very slow compared to natively compiled languages like C and C++. So one of the solutions to that got proposed was the idea of let's take the virtual machine and make it a physical machine in the processor. All well and good, but that actually gets very complicated. You can get better performance, but it really does not work in the most flexible possible way. So they end up with different things like they called it micro Java, they had ultra Java, also known as MAJC, or as we called it, Magic. Essentially, we abandoned that project once we got into the idea of just-in-time compilation, because that's much more efficient and much better as a solution. The Java ring. Yes, I actually have one of these that I collected along on my travels. Essentially, this was just what was called an I button, which is a little processor set in a thing. You often see people in restaurants where you need to identify yourself to a cash register, and they put their button on the thing, and it identifies them, and then you enter the things that they've got there. But again, this ran a JVM, which had 134 kilobytes of memory and 32 kilobytes of ROM, and it ran basically applets. Not really very useful. There's not much you could do with that amount of memory. But I remember at Java 1, they had this big display screen. And the idea was they gave everybody at the show one of these Java rings. And what you did was you go up and you plug your Java ring in, and it would calculate 1 pixel in a fractal. And over time, you could see the fractal image gradually created as people plugged their rings in. The Palm Pilot. Anybody ever have a Palm Pilot? What, nobody, really? Nobody had a Palm Pilot here? Okay. I had a Palm Pilot. So this was a sort of, again, before we had like smartphones, it gave you a lot of the kind of functionality that you had you have today on a smartphone, which is why we don't have Palm Pilots anymore. There was a virtual machine that was specifically developed for this, which was called the KVM, or Kilobyte Virtual Machine, and that fitted into 273 kilobytes, well, 273, why 273? 273 kilobytes of memory. Had a lot of Palm-specific APIs, so you could use like the stylus and interact with that through your Java, I don't know what they called that, the things that ran on there, probably midlets actually. Stylus input, address book, calendar, all those sorts of things. I actually still have my Palm Pilot. I dug it out, and I did actually get a midlet running on it when I started putting this together. The Amazon Kindle. If you had this particular Amazon Kindle with the keyboard at the bottom, that ran Java. So it had a JVM in it, which was specific to that. It was based on what was called the personal basis profile, used Java with AWT. It had a Kindle developer kit, which I must admit I never actually got to use that, and it ran kindlets. So everything in Java has to be a LUT. So you have applets, you have servlets, you have kindlets, you have midlets. Everything's a LUT. Then we had sunspots. Now, this is one of my favorite things that we had at Sun, because this was a research project that came out of Sun Labs. And it was all about looking at the Internet of Things. So smart devices where you could connect them as a network and create mesh networks and things like that. So it was a real fun device because it had an ARM processor in it. It had a decent amount of memory, well, 512 kilobytes, which is decent by standards in those days. And you could do all sorts of fun things with it. It had like LEDs on it, and you could do different things with that. And I got involved in several projects using that. Also had a sensor board so that you could have an accelerometer on it. So if you moved it around, you could do things. And they could communicate using Zigbee, which was the wireless networking, sort of a bit like Bluetooth, but not quite the same. And it had a specific virtual machine on there called Squawk that was written in Java, based on Java ME, but it was all written in Java. Again, that was sort of one of the research projects. These were great, but the real downside of them was they were very, very expensive. I mean, you could buy 2 of these plus a base station, which didn't have the sensor board, and that was $500 at the time. So it was just way too expensive to make any sort of commercial sense. Mobile phones was big for Java back in the day. This was before 2008 when the smartphone and iPhone came out. So there were all sorts of midlets that you could run on your Java phone. So if you had any of these different types of phones, then you could run midlets on them. And there were all sorts of APIs for doing messaging and mobile media and location and gaming and payments and all sorts of things like that. But of course, we don't use any of that anymore. Java TV, another project that I got involved in. And that was a really fun one because we were, again, going back to the very early days of Java and looking at the idea of putting Java on set-top boxes so you could have more interactivity between the user and programs on the TV. We did things like we worked with the BBC back in London, and we did tennis for the Wimbledon, where you could overlay different pieces of information. And as the viewer, you could select which information you wanted to overlay, you could select which camera angles you were doing and things like that. And as I say, I had a lot of fun with that because I got to go to TV trade shows, which are so much fun. Blu-ray players. If anybody's still got a Blu-ray player, it has Java in it. And it's one of those things where it sort of demonstrates that Java was very good at getting into devices, but we were very bad at making it clear that these devices had Java in them. If you've got a Blu-ray player, you could probably look on the back or underneath, and somewhere there'll be a very, very small Java logo. But it's going to be very, very small and hard to find. So you don't realize that it's got Java running in it. But again, it was the same idea of adding more interactivity. So if you had a film, you could have different tracks, and you could have the overlay of things like the director's information and stuff like that. So it was, again, interesting, but never really took off. And then the last thing I want to say, which is, again, I had so much fun with this in the day. Anybody remember Mindstorms from Lego? Anybody ever had? Yeah, a couple of people, good. So the first Lego Mindstorms was this big yellow brick, and it had an ARM processor in it, and it had 32 kilobytes of memory. And some people got together, and they created a virtual machine that ran in 32 kilobytes of memory and gave you enough space to actually do something as well. And that, to me, is just fantastic. I mean, it was so much fun. The idea of you running Java on a brick is great. So what you could do is you could interact with the sensors, you can interact with motors, and the most fun I had with this was I built a robot which played blackjack, and it used one of the video cameras that Lego also produced, recognized the card. It would then deal the card out onto the table. It used voice interaction through a laptop as well. And so some of the best times of my career was when I used to go to work and play with Lego. Right, so let's talk a little bit more about how we're doing for time. Good. Let's talk about how the Java platform itself evolved. So what we got in terms of features. This is not exhaustive because 30 years of Java, there's a lot of features that have been added. So I've tried to kind of keep it down to the most important and significant things. Right, so let's go all the way back to JDK 1.1, because of course this was like the second version of Java. What I've also done is I've added the names, the code names for the different versions. And it's just weird, because again, how hard is it to name things? So they came up with all these code names for the different releases. And so in this case, you've got Sparkler, Pumpkin, Abigail, Brutus, and Chelsea. I have no idea how they came up with that set of names, just random, really. But anyway, JDK 1.1 introduced the idea of inner classes. So you could do a class within a class sort of thing. It also introduced the idea of Java Beans, JDBC for database connectivity, remote method invocation, so you could have different virtual machines working together through an invocation of a method. Serialization, that wasn't in there until JDK 1.1, and even reflection in a limited form didn't come until 1.1 either. So 1.0 was really quite basic in terms of Java. And they also started introducing JIT compilation, certainly on Windows, in some of the later versions of 1.1. 1.2, that introduced a new keyword, strict FP, which, let me think now, yes. So strict FP, so technically that would break backwards compatibility because if you'd use strict FP as a variable name in your older code, it wouldn't then compile. Strict FP also now doesn't do anything since JDK 17, I think, if I remember rightly. Swing got introduced because AWT was not very popular. The abstract windowing toolkit, or the abysmal windowing toolkit, as most people refer to it. The collections framework, so all those good things like lists and sets and all that sort of good stuff. JIT compiler on the Sun JVM, and the Java browser plugin for applets, again, from later versions. 1.3, that introduced the hotspot virtual machine. So that was a big thing because that introduced the idea of adaptive compilation, the JIT compilation that we know and love today. A couple of small things, JNDI, the Java naming directory interface, and Java Sound got included in 1.3 as well. 1.4 was a bit bigger. So 1.4 was the first version to use JSR, a Java specification request, and it also included the assert keyword. So this, again, broke backwards compatibility because if you use assert as a variable name, your code wouldn't compile. Regular expressions got included, and the new I/O, non-blocking I/O, all of those kind of good things, they got included in 1.4 as well. Java Web Start, if you wanted to run applications on the desktop. then you could use that as a sort of deployment technology. Then, as I say, Java 5 had lots of big features in it, and that's why they decided to go from 1.4 to 5.0. This was called Tiger. I actually remember when we launched this, we had Graham Hamilton, who was the chief architect at the time, on stage with a live tiger, which is a bit scary. So that introduced generics, and because we introduced generics in Java 5, to avoid backwards compatibility problems, we didn't do it how you might describe as the way that it could have been done if we'd introduced it earlier. So the idea of type erasure, which causes all sorts of problems, then we had to do it that way to make things backwardly compatible. Applications, which of course has been so popular in terms of all the frameworks that we use, so that was introduced in Java 5. Auto-boxing and unboxing, which could easily be argued as a very bad introduction to the language because it makes it sometimes very hard to see what's actually going on. Enumerations, our third new keyword in the form of enum. And I remember saying to people, oh yes, don't worry about it. Nobody would have used enum as a variable name. And then I tried recompiling some of my own code and realized that I had used enum as a variable name. For each loops, which is a good idea, static imports and varargs. Oh, and the concurrency utilities, JSR166. All those things like semaphores and read-write locks and things like that. Yes, 5.1. So there was supposed to be a 5.1, a code named Dragonfly, but never got released. I skipped JDK6 because JDK6 was just, well, boring. Nothing really interesting in JDK6. JDK7, however, did have a lot of good stuff in it. Project Coin. Why was it called Project Coin? Because it was the small change in your pocket, so it was a set of small changes to the language. Strings in Switch. Can you believe it wasn't until JDK7 that we had that? Try with resources. Great. Really like that. Very powerful feature. Diamond operator, so the idea of type inference if you're doing generic types so that you don't have to specify the generic type parameter on both sides of the assignment. Simplified varargs, binary literals. Again, how did it take until JDK7 before we could actually put a binary number into a Java program? Underscores in numeric literals and multi-exception catches. And we got our first new bytecode, the invoke dynamic bytecode, which wasn't even used by Java. It was put there to make it easier for programs like languages like Ruby to have to get better performance because they're dynamically typed, and invoke dynamic works better for that. Yeah, just for completeness, JDK6 was codenamed Mustang. JDK8, that was a big one because, of course, it was the introduction of streams and lambdas, which gave us a functional programming style of doing things in Java, which we hadn't had before. New date and time API, yep, all good stuff. JDK 9 was kind of important because this was the first time that the Java community process voted down the JSR. And that was because of the idea of modularity, the project jigsaw, and they wanted to encapsulate all of the internal APIs. So turn off access to sun, mist, gun, safe. That didn't go down very well because it would break an enormous amount of code, like Spring, for example, that was using it at the time. So it was actually voted down, and they had to go back and make some changes, and then it went through and it got passed. I won't go through all 10 to 25 because there's like so much, but just a few highlights in terms of things that we've seen there. So local variable type inference, the var keyword, that was an interesting idea. Removing stuff, that was new from JDK 9. We'd always added stuff but never removed anything. So now we remove things like the Java EE APIs, JAX-B, JAX-WS, and the Corba, if anybody's still using Corba. Switch expressions, that was great, so allowed us to eliminate some of the potential bugs that we had in our code before. Helpful null pointer exceptions, that was a great introduction in JDK 14. Text blocks to allow us to do, include new lines and have easier ways of specifying text for our applications. A lot of pattern matching has been introduced recently. So pattern matching for instance of there. We've also got pattern matching for switch, unnamed patterns and variables, primitive types and patterns, instance of and switch, all of those things have been introduced over time. Records, sealed classes, virtual threads, that's proved to be very popular for certain types of server application. We've got foreign function and memory API, which is a replacement for JNI through Project Panama. and flexible constructor bodies. So yeah, lots and lots of new features. The other thing, just to briefly mention about that, was the idea of preview features, which we started when we did the 6-month release cadence, because that allows us to put things in, allow people to provide feedback, and then we still have an opportunity to change them if we want. So just to wrap up, I'm going to quickly go through this. Community in Java. So Java 1 was the conference that ran for a long time. In fact, it's kind of come back again now. And so that started in 1996, ran under Sun until 2009. The most people we ever had there was 25,000. And I just put a picture of all the badges that I got from the times I went to Java 1, and there's a much younger me there with Duke, as well as a picture of Scott McNeely with Steve Jobs when they were talking about Java on Mac. Java user groups, lots of Java user groups around, so obviously that we're part of Java user group here, and many Java user groups around Europe, lots in Asia and even in South America. The Brazilian Java user groups are huge. There's like 50,000 people, a member of the Sao Paulo Java user group. They don't all turn up to the same meeting. Lots of Java conferences around the world, so Java Zone, JFocus, JFall, Riviera Dev, DevOps, all the different DevOpses that you run around the world, DevNexus in America, JavaLand in Germany. And we also have Java Champions, who are people outside of Oracle who are selected because they help to promote Java as a platform. So I think there's a bit more than 403 since I put this slide together, so it's maybe like 408 now around the world who are, as I say, people who help to promote Java. I'm actually a Java champion as well. So just to summarize, Java, it was the right technology in the right place at the right time. So nothing in Java initially was radical or new. As I said, with all the things like Lisp and so on, all those ideas have been used before. It was just bringing them together in one place, and with the idea of the web and interaction through browsers and so on, that really made a difference. Has been very carefully nurtured by Sun and Oracle subsequently. I have to say that Oracle have done an extremely good job of keeping Java updated and adding new features in a very controlled way. Lots of open standards. Open source is all very good because that helps to make it a vibrant platform, plus the community as well. So the big question is, where will Java be in another 30 years' time? I don't think I'll be here to answer the question because I'll be 90. So I may still be here, but I won't be presenting. And with that, thank you very much.